Okay, so the next lesson for our unit of solving polynomial equations is to really review what we learned last unit in factoring polynomial equations as a strategy to solve them. But before we get there, one of the methods or strategies that we're already familiar with before we got to this course was something along these lines. For example, if we had let's say 3x plus 7 equals 8 plus 2x, for example. Okay, so notice the highest degree here in this equation is 1. We know how to solve these types of equations. We know that we bring all of our x terms together on one side of the equal sign, all of our constants on the other side of the equal sign, and then solve for x. So for example, we would do 3x, bring our plus 2x over and subtract 2x, and then bring our plus 7 over and subtract 7. Okay, so we'd end up with, say, something like x equals 1. Okay, so that we should certainly be familiar with. And then from last lesson, or from last unit rather, we learned that if our equation is of degree 2, all right, one of the strategies we can use to solve it is to factor it and place it in factored form, okay, and then find our x-intercepts. And that is one of the strategies to solve a polynomial expression. So we're going to go back over factoring in this lesson, and I'll go through it quick because I know we just did it in the last unit. Okay, just a quick recap. There will be one additional type of factoring which you learned last year, which we haven't touched on this year, and that's factor by grouping. And so because one of the things that we haven't really done is when you have a polynomial expression to the degree of 3, okay, and so you have something like this, let's say, okay, so something along these lines, okay, we haven't really learned how to factor this properly yet. We know that we can common factor it potentially, and hopefully if we common factor it, we'll be left with a degree 2 equation in our bracket or expression in our bracket where we can factor that expression. That's one thing that we've done. And we're going to learn another tool on how to potentially factor these, and that's called factor by grouping. Now we can't do factor by grouping in this example that I've just shown you. Okay, but that's another thing that we'll look at, is adding another type of factoring that we can do when we don't have a quadratic or degree 2 polynomial expression. So to recap, when a polynomial function is written in factored form, the zeros, or the solution, can be found by equating each factor to 0 and solving for x. So for example, if we had an expression that looked like this, okay, what you can do is set this equation equal to 0 so that what you're doing is finding what's called the y-intercepts anytime, the x-intercepts. Anytime y is 0 or f at x is 0, you're finding the x-intercepts. And so now what you're asking yourself is what letters of, or what values of x will make this equation 0 on the right side as well, so that the equation is satisfied, right? And to do that, you set each of these factors equal to 0, okay, and then solve for x. So x equals 5 here, x plus 4 equals 0, x equals negative 4. These are our two x-intercepts. These are what's called the solution. That's what x is equal to. Just like this was a solution for x, these are solutions for x. It's another strategy on how to solve polynomial expressions. But we're going to be given equations in standard form, and we're going to have to factor them to get them in this format here, where you have two factors multiplied by each other. So to do that, I'm going to recap what we looked at last unit. Okay, so for an example, 2x squared plus 9x plus 10, you have to find when a does not equal 1, well, either way, you always multiply a times your value here, your c value. If this is a, you multiply a times c, and you get 20. So then what you do is you find two numbers that multiply to 20, and those same two numbers have to add to your middle term of positive 9. Okay, so in this case, 5 and 4 satisfies both. Okay, and then take a look here. Take a look right there. This is important. Now to write this in factored form, once you found your factors there, rewrite the expression as follows. A times x plus m. Well, let's call this m and let's call this n. Okay? Let's call those m and n. Okay, just two letters just to call them, just so we know what to sub in there. So what you do is you take your a value. In our case, it was 2. Okay, our a value was 2, the first value there. Times it by x. Okay, then plus m. So plus one of our numbers that we found, which was positive 5. And then do ax again, 2x, plus the other number factor we found, which was 4. And then it says that we need to reduce each bracket if possible. Well, 2x plus 5 we cannot reduce, but 2x plus 4 we can reduce. There's a number that goes into both of them, so we can reduce that down. 2 goes into both. So 2x divided by 2 is just 1x, or x. So divide by 2, divide by 2. 4 divided by 2 is 2. And so there is your final answer. Okay, so that's just a quick recap from last unit. And now we're going to put that again into practice. Now, here we go. Our a value is 1. So we're going to do 1 times negative 18. A times c, right? A times c equals negative 18. So we need two numbers that multiply to negative 18. And they also have to add to our middle term, of negative 7. Okay? So how about negative 9, positive 2? That satisfies both. So then what you write is a times x plus m, a times x plus n. Let's call that m, let's call this n. Okay, now our a value happens to be 1. So we actually don't have to write anything for a when you have this case where a is 1. So we can simply write just x. So it's implied that there's a 1 in front of the x. Now plus m, but our m is a negative 9, so it's minus 9, right? Plus a negative just stays negative. And then x plus 2. Okay? Now it says for us to solve it, so we're not done yet. So set it equal to 0. X equals positive 9 here. X equals negative 2 there. Okay? Okay, next. Here we have an a value that is not 1. Okay, so keep that in mind. So our a times c is actually negative 70. So I need two numbers that multiply to negative 70, and those same two numbers have to add to negative 33. Okay? Negative 35 and positive 2 would satisfy both. Okay, so now all we do is write it in the form. Again, I'm going to stop writing this soon. Okay? Because you should end up getting the hang of it. A times x. So I end up with 7. My a is 7 right there. Okay, so 7x plus m, let's call that m and let's call that n, is minus 35. 7x plus 2. Okay, but we need to reduce each bracket. So let's do that first. So we can reduce this first bracket. 7 goes into both. So if I divide by 7 there, divide by 7 there, I'm left with x minus 5 times 7x plus 2. Now we need to solve for x, so we're going to set our equation equal to 0, let y equal 0, and say that this x-intercept is x equals positive 5, and say that this one, slightly more involved, I'm actually going to set this one, show that I'm setting it equal to 0. Okay, so you can see my algebra behind it. Then I'm just going to solve for x. Negative 2 divided by 7 is what you get for that x-intercept. Okay? So there's our two answers. So these have two answers for x. Okay, there are two different answers if you were to solve for x. Now with this question, remember that the first thing you always have to check is check if you can common factor first. That can make your life a lot easier. Okay, so you want to check if you can common factor. And certainly we can see, I hope, that we can actually pull out a 3 here. So before I factor, I'm going to see what's left over when I divide out a 3 from each term. I end up with 4x squared plus 5x minus 6. Okay, so now all I need, this is a little bit easier for me to work with. All I need now, if my a times c now is actually 4 times negative 6, so that makes it a little bit easier than 12 times 18, right? Do you see that? 12 times negative 18. Makes it a lot easier when you common factor first. So find two numbers that multiply to negative 24. Those same two numbers have to add to 5. Okay, how about 8 and negative 3? Okay, so next we're going to write this in our format of a times x plus m times a times x plus n. Okay, so I'm going to skip this step here. I'm going to jump right to it. Our a value is now 4. Okay, that's our a value. So I end up with 4x plus 8 and then 4x minus 3. Now, don't forget that our 3 is still here. Not that it matters. Sorry, that's a 0. Not that it matters in this particular instance in solving for x, but just keep it with your equation, okay? There is a 3 there. Then our last step is to reduce the bracket. So we can reduce this by dividing both of these by 2. So we're left with 3, 2x plus 4 times 4x minus 3. Okay? Actually, my apologies here, made a little mistake. It's not divide by 2. We can reduce it more than that, divide by 4, right everybody? 4 goes into both 4 and 8, of course. Okay, so we end up with x plus 2. Okay, so we have our equation. Now we just need to find what values of x will make left side equal right side to 0, right? So, well, if x equaled negative 2 on this side, certainly the whole left side would equal 0, because we'd be multiplying by 0. So that would satisfy our equation there. And then for this one in particular, I'll show my algebra here. 4x minus 3 equals 0. 4x equals positive 3. X equals 3 over 4. So our two solutions to this equation are x equals negative 2 and x equals 3 over 4. Okay? All right, moving on. Let's try something like this, where it's certainly a little bit more involved. And if it didn't have the squared, so to the power of 2, a degree 2 equation here, we would certainly be able to solve it pretty straightforward, but it has a degree 2, so there's going to be a few more steps involved. So the question is, where do you go to start? And what I would say is our strategy here is let's get rid of any brackets that are being multiplied. So like here, distribute the negative there so we can drop all our brackets. Then I want to move all my x squared terms to one side. And let's just see what happens when we do that. We're going to end up with x squared. We're also going to end up with an x term, and then we'll end up with a constant as well. Okay, so here's what we're going to do. Let's distribute 3x times x is 3x squared. 3x times 2 is positive 6x equals 2x squared. Distribute the negative sign there. So it's minus 4, and then minus negative x becomes plus x. So what I want to do now is you can see I have x squared and I have x. This is not like up here when I showed you that example where we just have to bring the x's to one side of our equation, our constants to the other side of our equation, and then solve for x. Not that simple because we have an x squared and an x, and we know we can't collect those as like terms. So what we're going to do when this happens is we're going to get everything over to one side of our equation, then collect any like terms we see. And you can choose the left or the right side, it doesn't matter. I'm going to choose the left. So I'm going to go 3x squared, and I'm going to bring my 2x squared over by subtracting 2x squared since it was positive on the right. Then plus 6x, bring my plus x over, becomes minus x. And then bring my minus 4 over, it becomes plus 4. Now, what did I leave behind on the right side when I moved everything to the left? I left behind a 0. And this is why now we can solve for x by potentially eventually factoring, because what this equation is saying is what values of x will make this equation equal 0, right? So don't forget that you're leaving behind a 0 here when you move everything to one side of our equal sign. So let's find the values of x that will make this equation equal 0. First, let's collect like terms, right? So we have x squared plus 5x, right? 6 minus 1, plus 4 equals 0. Okay, no problem. This is a simple trinomial that we can factor. Find two numbers that multiply to 4. Those same two numbers have to multiply to equal 5. Okay, pretty straightforward, 4 and 1. Now we write out our ax plus m times ax plus n. Our a value is just 1, right? A is just 1. So it's just x plus 4, x plus 1. Don't forget your equals 0 because all we're doing here is changing to factored form. We haven't solved anything yet. We haven't found the x-intercepts yet. Okay, so we end up with x is equal to negative 4 and x is equal to negative 1. Those are our two x values that will make this equation equal 0. Okay, let's continue on to example 3. So let's look at two different methods of solving as well. This one is going to be a difference of squares, and then I'm going to show you the factor by grouping example, just another way to factor a cubic function, okay? So far all we know how to factor a cubic function is by common factoring and hoping that after we common factor, there's just a quadratic left over that we can still factor, okay? But in this particular case, there isn't. So let's start here, difference of squares, okay? So now let's remind ourselves how to identify a difference of squares. First off, okay, you have to be able to, well, there should be two terms. They should be separated by a minus sign. Right? Remember the word difference of squares. Difference meaning minus. So separated by minus sign. And lastly, you should be able to square root each of the two terms. So square root each term evenly. Okay, evenly. So by not getting a decimal. So if those three items are satisfied, you know you have a difference of squares. And so the first step, okay, is that, and we do have that situation here. The first step is square root x to the 4, which is what? Remember that the square root of x to the 4 is really x to the 4 to the power of 1/2, right? Power to power law says multiply 4 times 1/2, so you're left with x squared. Okay, so this is the square root of x to the 4 is x squared. And then the square root of 16, and notice I don't do negative 16. You're just looking at the value after the minus sign here. That's a 4. And so all you do in that case now is you write it in your factored form. One bracket with a minus sign, one bracket with a plus sign. Okay, and fill in your first spot with the first value or the first term that you square rooted. Fill in your second spots with the second term that you square rooted. Okay, and remember equals 0. Okay, but that's not totally done yet. I hope you can see that while x squared plus 4 is good to go, we can't do anything with that, we actually have another difference of squares here. We have to actually factor it again. Okay, so we have to factor that bracket again, that factor. So we're going to square root x squared, which is x. We're going to square root 4, which is 2. And we're going to get x plus 2, x minus 2, right? But don't forget that this is still here as part of our equation. So please don't forget that. So x squared plus 4 equals 0. Okay, so let's find this x-intercept and then this x-intercept, which should be easy enough. So what values of x here will provide us with 0? So x equals -2, x equals +2. Now, when you're finding this next x-intercept, something interesting happens. So far we know that -2 and 2 are x-intercepts, but here, look what happens when we set this equal to 0 and solve for x. Let's observe here. We end up with x squared equals -4. Now, to solve for x, we know that we would have to take the square root of -4. Is that possible? No. Okay, so no, this does not exist. This is not an answer. This is not one of our solutions. Our only two solutions exist. These are called real roots. They only exist, it's only these two that exist, are -2 and 2. And if you look at Desmos and you look at the graph of this function, you'll see that that is in fact the case. So I graphed this exact factored form equation that we got, and you can see that we have two x-intercepts, two solutions, -2, 0, and 2, 0. And we have nothing here shows that there was any sort of x-intercept for that x squared plus 4 factor. Okay, so there's nothing there that shows that. So let's see if that happens again in this particular question. So here we go. I mean, when you look at a cubic function, look to see if you can common factor it first. And the fact is you look there, you have a 1, a -4, a 5, and a -20. You can't common factor anything out of there besides 1. Okay? So another thing that you can do to try to factor this is called factor by grouping. What you do is you split your 4 terms down the middle. Okay? So 2 on the left, 2 on the right. And you're going to common factor each group separately. So, for example, this first group, I see a common factor here. What is my common factor between x cubed and then -4x squared? Well, I see that I can pull out an x squared. That is what's common. Okay, I can pull out an x squared. Here, I'll make this a little more clear. Okay, so let's divide out an x squared out of both and see what we have left over inside my bracket. X cubed divided by x squared is x. And then negative 4x squared divided by x squared. Well, the x squares cancel each other out, and we're just left with minus 4. Okay. Now, I am going to factor out, what should I common factor out of this second group here? A common factor here would be a positive 5. And so I don't want you to just write 5 here, because you have to write, we're adding here. We're adding. We're not multiplying. Don't just put a 5, which shows that you're multiplying all of this together. It's plus, so whatever sign is in front here, you put down here. You bring that down. So it's plus 5. Now open a bracket. Okay, now let's see, after we divide out 5s from here, what do we have left over? 5x divided by 5 is x. Negative 20 divided by 5 is negative 4. Okay, at this step, you know you did it correctly, or that you can factor by grouping if you get the same brackets. Same brackets here and then here. They should be the exact same brackets. They should be identical. They have to be. If you are factoring by grouping, those have to be the same brackets. Otherwise, it's not possible to factor by grouping, or you made a small mistake somewhere in your common factoring. Okay? So this question, we can common factor it, or factor it by grouping. And now what you look at is you have an x squared times x minus 4 plus, okay, there's a plus there, 5 times x minus 4. My question to you now is, what is common between these two terms? Because we do have two terms here. This is one big term. This is another big term separated by a plus sign. What is common between these two groups now? X minus 4 is common. So I can pull that out. Pull out the x minus 4, open a bracket. Let's see what's left when we divide out an x minus 4 here in each side. What is left? Okay, well, the x minus 4s cancel out here, and you're left with an x squared. They cancel out here, and you're left with a plus, right? Plus 5. There's your equation in factored form. Okay, so this was factor by grouping. I split my 4 terms down the middle, and then I looked, okay, can I common factor the first group? Yes, I can pull out an x squared. Can I common factor the second group? Yes, I pulled out a plus 5. Okay, then I common factored once more because I saw that my brackets were x minus 4 for each term, which means I can divide it out. It's common in both. I can divide it out. And what I was left with was your x minus 4 times x squared plus 5, after the x minus 4s ended up canceling out. Let's write your x-intercepts. Look at this one. Once again, can you take the square root of a negative number? No. So this is actually not an x-intercept or a solution. The only solution here that is going to make left side equal right side to 0 is x equals positive 4. There are no other values that will make this equation equal to 0. Okay, there's only one x-intercept. All right, so that does it for this lesson. Okay, if we summarize, all we did was we went back over factoring. Okay, we went back over difference of squares, and then we looked at this example of factor by grouping. You definitely need to practice some of these, okay? And there are some practice questions in your homework, okay? And this was just another way that we can solve equations, but in particular, solve equations that are not of degree 1, right? Because up here, when we first started the lesson, I showed you an equation of degree 1, and it's pretty straightforward to solve, right? In all the questions in this lesson, we had degree 2, and then we even had a degree 3 as our last question. And in the degree 3 equation, we employed the strategy of factor by grouping. Okay? And then one more thing, we saw that when one of our factors is an x squared plus a number, like x squared plus 4 or x squared plus 5, those don't end up providing us with any x-intercepts, because you're going to end up taking a negative taking a square root of a negative number, which simply doesn't exist. Okay? So that is it for this lesson.